started. It's 9:01. Welcome everybody to OpenCV weekly webinar. And today we have one of the teams from OpenCV AI competition called Rocfort, who have built this amazing, cow detector, and they will present what the process they went through to create this solution for the competition. And with me are Arnaud Batista from Rocfort, and also Pierre Nicola from Pixelia, which is they basically produce a framework which allows you to train your models very easily on the cloud without doing without even knowing coding as such. So, and also, as always, we have Phil Nelson, who is the content manager at OpenCV. Welcome, everybody.
Hey, folks. Welcome back to the webinar. As usual, we will be doing Q&A at the end of the session, so please use the Zoom Q&A button to ask your question at any time during the presentation, and we'll do our best to answer as many as we can at the end. There will also be a trivia question and giveaway. Would you like to tell them what they'll win, Satya?
Yeah, so there are two prizes today. First of all, because Microsoft and Intel, they are sponsoring the competition, we get 200 hours of free Microsoft Azure credits. So that's prize number one. The same prize will be given to, the second prize will also be given to the same person. It's basically a combination of two things. This is from Pixelia. They have been very kind to offer 10 hours of free processing time on their system, so that you can train your own model there.
Big giveaway this week. Big giveaway.
Yes. So it's two different platforms, and you can try and get your hands dirty training a machine learning model. All right, so let's begin by introductions. Arnaud can go first and introduce himself, and then we will go. Pierre can introduce himself also, and then we will go with the presentation.
Thank you, Satya. So I'm Arnaud Bastide. I'm Rocfort team leader. Our team. I'm based in south of France. I'm active in the, let's say, computer vision field since about 20 years now, so it's not getting me young. And it would be a pleasure for me today to present the work we achieved with the Rocfort team during the OpenCV Challenge.
That's great.
And I'm Pierre-Nicolas Tifros. I live in the south of France, just as Arnaud, and I'm the co-founder and CTO of Pixelia, where we develop cloud software for AI development.
That's great. So yeah, let's get started with the presentation. What are we going to learn today, Arnaud?
So today we are going to learn how to apply some computer vision and DL technology to animals, and specifically to cows. So yeah, we'll dig into it, and also how to integrate it into the OpenVINO framework in order to apply it to edge device like the Oak, of course.
Right. That's great. I mean, while you set up the presentation, put up the presentation for people to see, I just wanted to say that this, again, is a very big area which is growing. People are using computer vision for animal husbandry. I know at least 2 or 3 projects that came by our way. We did not work on all of them, but we had very good talks with people who wanted to solve some of these problems. The cow one, which Arnaud is going to present, one is one. We also saw pig face recognition. They wanted to know, how people are doing, how pigs are doing. And the good thing is that they come to drink water. So if you put the camera right next to where they get to come, come to take water, it's a very good place. You can get a very good shot of the face, and then you can, track them, etc.
If I can say a word about it, yeah. I was also in touch with a laboratory from Switzerland and they have some, let's say, they have some troubles to apply the vaccination because, contrary to the cause, in France it's the case 100%, but not in all the country. If the animal don't have identification on their ears, they cannot know which pig have been vaccinated or not. Right. And in the top of that, because they need 2 vaccines, so they don't know which one have been vaccinated once or not. So they was also very interested in pig face detection, tracking, and also the next step would be, of course, the recognition. That would be
right.
Very,
and
maybe for the
thing, I mean, the way it is done currently is that they literally staple something on the pig's ears, and they have, the pigs obviously don't like it, and they can tear it, they can remove it, right?
What I heard is that in some countries, and for example in Vietnam, one of the teammates is from Vietnam, so I'm happy to talk about it. There are some really big farms with a lot of pigs, and they are not identified. They don't have any way to identify them. So it's really a big problem. They are trying to find against another disease. It's fever, porcine fever, and it's a huge problem at the moment in the world.
Right. And then I had another company approach us. This was a company in South Africa. They wanted to, and there they apparently they have very large farms. And in these farms, the cows, they graze, and in the end, at the end of the day, they need to figure out, if all the cows are back home or not, and if there is some danger during this. And there is also a big problem with stealing. People steal other people's cows. So the idea they were thinking about is that they would run drones. They would fly drones over these and count cows. I mean, it was more complex because cows could be under a tree, things like that. But that was the idea. So a lot of activity going on.
Yeah, I will have chance to show some demo about tracking and counting and going to that way. I mean, trying to solve it.
That's great. Okay, let's start with the presentation. Sorry for the.
No.
Let's move on.
Right.
Okay, let me share. Can you see properly?
Yeah.
Yes.
Looks great.
Okay. Okay, so let's say
Before you get started, can you tell me what kind of cow that is?
Okay, we call it limousine, like the cars, because of course, the cars, the luxury cars.
Are they very long?
Yeah. So yeah, the name, let's say the race of these cows are limousine. It's very specific of the region here.
Okay, cool.
And where you can see here is the lands, the field close to my house, where I have the chance to go and to take some picture of the cows.
It's beautiful. It's a lot different than I think a lot of computer vision work, the circumstances under which it is done.
Yeah, that's different.
So yeah, today, during the challenge, so our goal is to try to improve animal healthcare, so with computer vision and AI. So the plan of the presentation, I will first of all say another word about the Rocfort team. I will introduce the context of our project. And then I will explain how we implement 2 main features. So code tracker using YOLO V4 pre-trained model and deep sort algorithm, and how we train our own model for co-face detection, and on how we integrate it to OpenVideo, and how we use also the deep sort to track the face. And of course, I will show you some demo of all of that. So here's the team. Jorge Luis Perez Medina is a professor researcher in computer science. He's from Ecuador. He is professor. No, sorry, he's from Venezuela, but he's professor in Ecuador. So that's one of the reasons we compete for the South America region. Nguyen Ung, our coding master, I want to say, is from Vietnam and is a computer vision engineer. And myself, Arnaud Bastide, as a computer vision engineer too. So let me say a word about the activities of Rocfort outside, let's say, a part of the challenge. So we focus on the. I'm from the security field, so I developed in the past some computer vision feature for example, intrusion detection, people counting, car counting, also car behavior detection. But you're using pure computer vision algorithm. So now, of course, we are also moving to deep learning algorithm. And we are implementing some feature mainly for city surveillance. For example, air crowd monitoring. So here we are using incredible, let's say, models trained on the wider face data set in order to be able to detect face. In fact, the idea is to detect the face and at the end to be able to count the person in a very difficult situation. Unfortunately, it's very popular at the moment in France because of some troubles due to the sanitary situation. Another feature module we are working on is the face blurring because we have some rules about privacy respect. So when using export files from city surveillance camera network, we need to blur the face of the people not involved in the situation. So that's basically two of our, let's say, products we are working on. So let me show you a short video to explain the context and why also it's very important here to use a non-intrusive sensor to, let's say, to improve the healthcare. First of all, we are not in the case of industry or, let's say, farm, and as you can see in the video, it's a very traditional way to feed the cows and etc. So basically, during the day, the cows are outside and they are peacefully eat the grass, and every evening they are coming back to the farms and they can feed with their milk the babies. As I said, it's very traditional. Of course, no GM in the other foods we give them. So you can see here they are just very beautiful. So here you can see a typical farm of our region. There is about 600 farms like this in the area outside around my place. And there is it's the way they grow up and all have a label, so it's something we have to respect a very strict way to do it.
That looks very good.
So, as I said, I'm a computer vision engineer, but I have the chance to grow up in the farm, in one of these farms. And yes, since years and years, of course, I'm trying to find a way to apply computer vision to solve real world problems for the animals, for the cows. Using, let's say at the beginning, or let's say 15 years ago, something like this, it was very difficult to apply pure computer vision filters to, let's say, to analyze the behavior. One of my first ideas was about the calving detection. It was, but now there is some sensor to be able to do it. But now with deep learning, we have more information about, let's say, we can analyze more in details the animals, and we are able to do more advanced feature. So as you said as an introduction, Satya, there is, as you can see here in this diagram, there is a lot of potential applications.
Right.
So, for example, in the grow optimization, in the activities, in the nutrition. But here we want to focus on the healthcare. So, as I said, there is the calving detection, and the second one is the respiratory illness. There is other, of course, like, for example, in inflammation from it's possible to use some thermographic camera also to detect some inflammation. It's more used for horses because it's that have cost. But again, there is a lot of problem to address.
Right.
So our motivation is to reach an application able to fight again bovine respiratory disease. You have to know that it's the most common and costly disease affecting beef cattle in the world. It's a bacteria. It's an infection due to a bacteria, and it causes pneumonia in the calves. Actually, the diagnostic is very complex because when you have cows, let's say, moving freely in their park or etc., it's the only way to detect it and to prevent it is to have a measure of the temperature. So it's really not applicable to every day to go for each calf and to measure it. So the goal in the near future is to, once we have the cow detector and the face detector and tracker, is to also to apply thermographic to use also thermographic cameras to have the measure. But before that, we need to have a very precise detection and tracking of the face, because the measure have to be taken at very precise places, area, typically around the eyes. Another way to fight against this disease, and complementary way, is the vaccination. So basically all the calves are vaccinated. And as we said as an introduction, what we said for the pigs can be also applied for the cows, of course. So yeah, so during the project, I will show so the code tracker, the face detector, and I will not go deep into it, but we also try some libraries like OpenPeacePath. I don't know if some of you heard about it before, to have also the pose estimation. It's can be also very interesting for other applications, but it was quite impressive to see that we can apply pose estimation to the codes.
Right.
So technically speaking, because we want to solve also we want to solve the problem in the shortest time as possible. We don't want to go from scratch and starting coding all the features. So we used the OpenVINO toolkit, the Picelia ML platform, and our favorite edge device, which is the Hawk. So that allows us to work different teammates work on different environments. Actually, some are more Linux guys, some are more Windows guy, and also it ensures the OpenVINO development and ensures the compatibility with this device.
Thanks.
And of course, people can pick up their own OKDs at shop.opencv.ai.
For a ridiculous price of
an extremely reasonable price. Yes, you're correct. It says you won't believe it.
Yeah.
So now, so as I said as an introduction, there is two separate, let's say, applications, and all of them are available on our GitHub. It's the code tracker and the co-face model detector and tracker. So it's separate.
Right. Just to be clear, the cow detection and tracker, somebody can run it on their own computer also, right? This doesn't necessarily require OAK-D. So if they have access to your GitHub repository, they can simply take that model and run it on their laptop also, right?
Yeah.
Okay.
Correct.
Okay.
So we will follow the different parts. So I will try to say some words about OpenVINO because I think it's very important to understand, let's say, the benefits of this platform, generally speaking. And you can also refer to the latest articles on learnopencv.com.
Oh, you saw that. Yeah, we have an OpenVINO series going right now. We have 3.
Yeah, I found it very helpful, and there is some part of it in the presentation. I hope you don't mind.
Oh, great. No, thanks.
So OpenVINO is, as I said before, cross-platform toolkit developed by Intel. So the name stands for Open Visual Inference and Neural Network Optimization. And so OpenVINO focuses on optimizing neural network inference with a right to answer and deploy anywhere the approach for Intel hardware platforms. So the workflow we have to keep in mind is, first of all, you can create your model or pick one of the pre-trained models. So from a DL framework like Picelia or others. I can also name RoboFlow, of course. There is other way to get it. So after that, you have to convert your model to what we call the ER format. And then we have the tools to run the inference and deploy it, of course.
Right. Can I just give a little bit of context to people, some of the beginners who may not fully understand, why this thing is important. Now, when you typically train a model, right, if you are just starting out in deep learning, you would pick one of these frameworks like TensorFlow or PyTorch, and then you would use it to train your model. You would, optimize the model so that the accuracy is high. But once you're done, that model usually is never put on in production. you optimize that model for speed, accuracy, etc. Basically for speed, you try to make that models really small if you want to deploy it to an edge device. So the goal of of these frameworks, TensorFlow and PyTorch, is usually to train a model in perfect condition, right? You have access to a GPU, you have all the time in the world, etc. But this model, when you want to deploy it to the edge device, like let's say a smart camera or a small computer, in that case, these models, you have to optimize a lot, right, before they can actually be deployed. There are many paths to it. So companies like Intel and NVIDIA, they know that, you cannot use these models directly. So they don't care, Intel especially, they don't care about training framework, right? They say that train using PyTorch or TensorFlow. And then once you have this model, we are going to provide the tools so that it runs very efficiently on our processors, on our VPUs, GPUs, etc. So NVIDIA, if you're using the NVIDIA toolchain, you would go for TensorRT. And if you're using the Intel toolchain, then you would go for OpenVINO, right? Okay, now we can go.
Thank you very much. So after running the model optimizer, as you said, we get an intermediate representation, which is two files actually, an XML and a bin file. So that you have, as you said, there is some ER representation already available that you can run directly for some models. And then you will use the inference engine typically to check the model compatibility based on the framework and to deploy it to the hardware. As you say, there is different frameworks supported by OpenVINO, TensorFlow, Caffe, MXNet, ONNX, Caldi. So basically the most popular. So to summarize, the biggest benefits is that it supports neural network architecture for computer vision, also for speech and natural language processing, not only video processing. It supports a wide range of Intel hardware, including CPU, integrated GPU, BPU. There is you have access to the models, to the official model zoo, so you can get there a lot of pre-trained models. And then you can optimize, use the optimization tools to speed up the scalability of your neural network deployment. And also, of course, OpenVINO Toolkit provides the OpenCV library for video and image processing. So here I've just put some supported hardware, and I also put the new version of the OpenCV camera, of the Luxonix
it's
camera.
Like OAKD PoE there.
Yes, yeah. I think would be very popular because it can be very useful for to deployment on the network, video camera network, etc. So
the PoE stuff is really popular for robotics, but also for facility use because it's many fewer cables,
Yeah.
Right.
Yeah.
So it basically powers over the Ethernet cable, right? So that's one thing. The other feature about this feature for this one is that it is also waterproof, right? You can use this in conditions where you cannot use OAKD, especially, let's say it's, IP67 compatible and things like that, which is makes this waterproof and things like that.
Much safer to leave outside.
Much safer to leave out. Thank you.
Yeah, I think I already love it.
Yeah.
Just a quick word about the installation. It's quite easy. There is some GUI installer and all, but I have to say from my experience, please follow really strictly the installation instructions that can be the better way to achieve your installation. All is documented, but don't miss any part. And so at the end, you will have all the software dependencies installed, like the model of course, the optimizer, the inference, the OpenCV, the deep learning inference engine, and the deep learning model optimizer. Do not hesitate to run the demo application to check if everything is okay. But generally speaking, if you follow the instruction, it's going to work. So as I said before, you need the XML file which contains the neural network topology. So all the architecture of your neural network, so all the operation such as convolution or max pooling, etc. So all the data flow between them, and the binary file which contains the weights of the network model. You can use the tool their workbench to always also have a look to the graph. It's a very useful tool. Conversion model. So in this example, in our example, we have addressed two cases: TensorFlow to OpenVINO, and Darknet for the EuroV4, the one we are talking about just now, to OpenVINO. So you can see for different frameworks, there is can be different steps to follow. Something also very important is to choose the appropriate precision format depending on which hardware you want to infer your model. So for tracker, for let's say for the code detection, for the let's say the pre-trained model, we choose we work with EuroV4 and we use the square version, squared mesh version to be more precise, because it's as you can see on this diagram, it's very the performance are really good on the COCO object detection dataset. So you can see here an example as we was talking about before. If you want to count, let's say the cows on the field using a drone, for example, can be a solution. Of course, if the cow is hidden, but okay, you can have multiple counting, not only one shot. Basically, it's working good. But for the tracker and let's say the edge deployment, we use the EuroV4 tiny model. You can have a look to the Learn OpenCV article I was mentioning before. There is all the details to convert it to OpenVINO. Basically, today and with OpenVINO, EuroV4 Tiny is really a good trade-off between performance and accuracy. It's really working good, I can say.
Did you try other models and chose EuroV4, or this was you read online?
Yeah, we tried EuroV5. Okay. But we still have some issue converting the model in a proper way to OpenVINO.
Okay. Interesting. Okay.
So on the top of the detector, we try two different object tracking algorithms. So let's say by default or sort, the algorithm sort. So for simple online real-time object tracking is available. The implementation is available in OpenVINO. So basically, the process is to detect all the object in the frame, predict the new position of the object based on the previous frame, and to associate the detected object and the predicted object to assign the ID. So that is okay. You can see here how the matching is working using intersection over union matching, and the prediction using a Kalman filter. But we figure out that in the real world, for real world applications, there is some limitation. For example, when the object is hidden between two frames, etc. So we decided to go for DeepSort, which is very popular at the moment as an object tracker. There is others, but DeepSort is seems to be very popular at the moment. And as you can see, there is some improvement in the track life cycle management. That is, let's say the tracks are not deleted immediately. They are stored somewhere, and they can be used again in the future to match with the same with the previous track. So and also the prediction is not only intersection over union. There is also a matching based on Hungary algorithm. So basically, there is a computation of a crossing distance between the embedding vectors of the object extracted and the track. So we saw some very good improvement, and as you can see on different demos on at the moment, is giving very impressive results.
So now one thing I just want to clarify: tracking is, in computer vision, tracking is overloaded. The word tracking is slightly overloaded in the sense that there are two different kinds of tracking algorithms. One is in traditional computer vision algorithms. What we used to do is, given a frame, you had one detection, and then you would try to predict forward where this object is going, right? And in that case, you would do something like a template matching. Not always, but I'm just picking the simplest example, where you would see where this template has moved. So you would try to figure out where and you would do a pyramid so that you could cover multiple scales. But it was an appearance-based thing, right? It was based on how closely the appearance of the object matches in the next frame. And based on that, you would say that, okay, the object moved forward. But in deep learning context, they switched it slightly. What they said that you have detections, for every frame, they would do the detection. And then you have, for every frame, you have a bunch of rectangles. So in frame 1, let's say you had 5 bounding boxes. In frame 2, you had 6 bounding boxes. And the goal would be to associate one bounding box in frame 1 to one bounding box in frame 2 and see if new bounding boxes were produced. So it's slightly different, the way the two things worked. One is based on appearance, and the other is based on matching the bounding boxes, right? And of course, you can have a hybrid that you also look at the appearance inside the bounding box. Okay, go ahead.
Thank you very much. So in the meantime, I was showing some, of course, some demonstration in our case. So as you can see, for each detection, there is the label, let's say the ID for each object.
Yeah, and so it's not just tracking these; it's actually able to re-identify them. Is that true?
Yeah, it's we have the ID associated for each detection. So now I will try to speed up a little. So now, so at the end of this work, let's say we have a complete framework to import and converting a model into OpenVINO, and we are able to track the object. So now we will apply it to the face of the code. So for this, there is no pre-trained model. So we will use an ML platform to build the custom model. And then we will follow the same process. So of course, when you want to build your own model, you have to build your dataset. So the first step, of course, is image collection. Actually, building the data set and training the model is a never-ending story, so it can be always incremented and trained to improve the performance. So as I said, we use the Pixelia platform, so they are provided different tools. So here the annotation tool, so you can easily draw the bounding box around the face, for example, here. After that, you can pick your model. There is different model you can use. In our case, we use the MobileNet V2 models. It's an SSD. So we choose it for the convergence of the speed of convergence and the accuracy of this model. And it's also quite let's say, it's a quite good model for edge applications.
Yeah.
After that, you have to, of course, to train your model. So there is 3 different possibilities. You can integrate the Python SDK. You can use a Docker image, or you can use a Google Colab notebooks to train it. We use Google Colab to do ours. When you are done, you have the possibility to test on the. So of course, when you are training a model, you have the data set for the training, and there is about 20% of the image you can use to test and to validate the model. So here in the web interface, you can test on you can validate your model on the test image and see how good is it. So here is some demo. That's our demo of. It's just the detection here. It's the pure inference of the model. There is no tracking here. I will show the tracking later. So here, so before we convert a EuroV4 model, here we convert an SSD model. So it's exactly the same process. So we have the frozen weight, and then we will pass them through the model optimizer to obtain the files. During the challenge, I was part of some let's say group of discussion on WhatsApp, on other Discord group or whatever. And here we have tried to document it. I mean, as clearly as possible the model conversion. I think is maybe the more difficult part of the process. But for SSD, if you do all things properly, it's working. So we need on the we have a TensorFlow. We use a TensorFlow framework. So we have to use the script for TensorFlow, which is this script, TensorFlow 2. So you have to give the path to the frozen weight. You have to give the path to the pipeline configuration of your model. And also you have to specify the object detection API so the optimizer will know how to replace the custom operation. And also, because we have image in a RGB format, but in OpenVINO it's BGR, you have also to specify to reverse the input channels. If you do this properly, you will obtain and will be able to run your model.
Yeah, the funny thing about that last piece is that, if you miss that, it's not like it will not work. It will just work worse, and you would be scratching your head where it is. It's not like, oh, it's giving 0 result, right? It will give you some results a lot of times, and just because you have not done the channels properly, it could be annoying, right? Because that would be difficult to find that, oh, you're not doing this.
Yeah, and as a final demo, I can show you here. So the integration with also with the deep sort algorithm, so we can have an idea for each cause. And
so if people have to take, at a very high level, right? If people have to take this, suppose you're creating an object detector and tracker for an edge device. I just want to summarize that people should be able to just pick up, MobileNet V2 for the detector, deep sort for the tracker, combine the two, and they will get some reasonable results. Is that fair to say?
Yeah.
Yeah.
Correct.
Okay.
Yeah, this pipeline is applicable to different use cases. So yeah, that's why it was very interesting to have the full process. So and apply it to our particular context.
Right. And OpenVINO, it's also very useful when you're trying to do in production, if you want to use this on CPUs, if you are deploying this thing on CPUs, your deep learning model, it works great. You can just get 30-40% improvement free. And the first, we used it a few months back in an application which was running at 20 frames a second on a CPU after all the optimizations. And we just ran it through OpenVINO, and it suddenly became 30 frames a second, and now we can call it real time. So it's almost like when it works, it's almost like it's free, that you got this free thing for very little loss in accuracy.
And you can also use CPU for some task and GPU for others. Yeah.
Yes.
Okay, so now we have another part of the presentation where we will go more in deep on the model building. So maybe a 10 minutes presentation about that. So I will stop sharing my screen.
So we're at about 9:50 here. How about before we do that, let's do our giveaway so we don't run out of time. Does that make sense?
Okay.
Yeah.
All right.
Cool. So for folks that are just joining us, or this is their first episode of OpenCV Weekly Webinar, the way this works is I will ask a trivia question based on the slides of the presentation so far. The first person to give the correct answer to that question, as it shows up on my screen here in the Zoom chat window, will win. Would you like to tell them what they'll win, Satya?
Yeah, so they'll win two things. First of all, 200 hours of Azure credit, and this is sponsored by Microsoft and Intel. And we will also, they will also receive 10 hours of free compute time. And this is courtesy Pixelia. Yeah, and thank you so much, Pierre, for offering that.
Definitely. Thanks a lot. We really appreciate it. And I'm sure the winner will as well. So fingers on buzzers. During the presentation, we learned a bit about a specific single shot detector that they chose to use. Which is that for face detection? And it looks like the first one to get it, the correct answer was MobileNet V2. And it looks like the first person to get it correct was Mario Bergeron. I think this is the second time Mario's won something. You're too good at this, Mario.
Nice.
So congratulations. I'll be in touch to give you your free stuff.
Congratulations, Mario.
And
so yeah, go ahead, Steve.
Yeah, so the next part of the presentation is by Pierre. And if people, I know that a lot of people have a hard deadline at 10, we will have recording of this webinar, which we will post in a couple of days. So nothing is lost. We will still cover everything. And it's a very good platform. So let's hear from Pierre.
Yeah, thank you very much. I will try to do as fast as I can so everybody can enjoy the whole presentation. I'm just gonna share my screen. Is it okay for you all?
Yeah.
Yes.
Okay.
Looks good.
Perfect. So first of all, I'd like to thank Arnaud and the Rocfort Tech team for inviting us and me, Pixelia, to participate in this webinar, and OpenCV, of course, for animating such events. So as I said earlier, I'm Pierre-Nicolas Tifro. I'm the CTO and co-founder of Pixelia. We are a French AI startup funded 2 years ago. And basically what we do is that we develop cloud-based softwares for that companies can use for their machine learning, deep learning engineers or practitioners to handle the whole lifecycle of their AI project in one unique place. So before discussing today's topic and the Rocfort Tech project, I just want to recall some of the main pain points or difficulties that anybody encounters during a computer vision project, especially when working with deep learning. So first of all, you have to find the best resources in the state of the art for your project. Then you know that the most painful point usually is data collection and annotation. After that, you must find ways to iterate seamlessly over your experiment until you're happy with your trained model. And during the steps, you should be able to collaborate with the different persons in your team and have at least a basic knowledge of the field. So what you're going to attend is the story of how we try to solve each and every one of those issues or requirements with Arnaud, thanks to our platform for the OpenCV challenge. So as you saw during Arnaud's presentation, the goal of this project was to create a co-phase detector that could work on edge device. The advantage of this project is that it was easy for Arnaud to collect the first pictures for the prototype, which is a relief for one of the main pain points I presented before. But now that you have the pictures, you have to annotate everything to build a usable training data set. So just like we can see on these pictures where we annotated Marguerite's face. To annotate its data, Arnaud counted on members of his team to help him. So this collaboration process implies a few requirements, such as the ability to annotate the same image multiple times and doing consensus afterward, and also the ability to review easily and have dataset metrics available to ensure the best quality. So here, as Arnaud showed us also earlier, you can see what annotation looks like. We can find the element I just described. So on the left, you have the different annotations from different people of the team. And on the images on the bottom of the page, you can see the review status for each image. Usually, when you work on computer vision projects, you have a high chance to be collecting data continuously during the project duration, but you might want to work as soon as possible with the data you have at a given time. So that's where versioning is important. It allows you to create and work with different versions of your data while always guaranteeing the integrity of your work and knowing on what piece of data set your models are trained on. Here we can see that Arnaud started with a small data set that has already collected at the beginning of the challenge, and that he made it grow over time. Here we certainly have the images of the first version in the co-phase 2 version, but at Pixelia, we only keep references to images in order to avoid unnecessary copies and waste of storage. As Arnaud said in the beginning, there were a lot of farming use cases that can be addressed with computer vision. And thanks to versioning, we could have different annotations on the same dataset for each use case, for example. So here we can quickly see the overview of what the dataset looks like after it has been annotated and reviewed. So as you can see, one can use the search bar and our data core language to quickly find annotations according to some properties.
So Pierre, one of the benefits of using tools like Pixelia is that you're not moving a lot of data around, right? You have this data set, and you can do face detection on it, or you could also do segmentation on it, right? And it's the same data set. You don't have to move it around and create additional copies and things like that. It's all neatly arranged.
Yeah, exactly. For example,
and the other thing I heard is that you also, because suppose you have 500 images, right? You can still train a model with it. It may not be as good as you want, but when you have a model, you can actually predict, you can actually apply it to the rest of the data set, the new data set that comes in, and only choose pictures where there is a failure case, right? So that's also very important in these interfaces.
Yeah, sure. And for example, we could have created a detection data set like Arno did, and then use the same images, but in another version for segmentation or even key points or whatever.
Right.
So yeah, Arno showed you also this step earlier. So now that is the time to start training our models on the current dataset we have. So for me, training goes through three important phases. So first, you have to find usable architectures with guides on how to use them, though that's basically state of the art. Then you have to track your training metrics and logs so you're able to analyze and compare your results of training later. And finally, a good thing for computer vision is to be able to test every model live against each other, so you can qualitatively compare them and see their strengths and weaknesses on different cases, for example, night and day or at different scales. So at Pixelia, that's why we propose the model hub, where Arno find his architecture that helps with the first part, sourcing models, and allows them to quickly start their implementation. That's quite inspired from libraries like OpenCV that permits to do a lot of experiment out of the box to kickstart project without any hassle, in my opinion. Okay, so this is just to show you the global organization of Arno's projects. So we can find the different dataset versions you worked with, a list of the last experiment that has been performed. And on the right, you have a complete history of every action that has been done by any collaborators, so to ensure traceability, which is also an important thing in AI projects. If we dive deep on one of the project's experiments, we can see here rapidly the most important information in just a glimpse, such as the dataset used, the model used, the hyperparameters. And below, you will find all the different metrics and logs resulting from the training, such as the train test split of the dataset or the loss curve, for example. One can also add comments and tag other people in the team to collaborate seamlessly. So as we can see, the metrics we track here are the COCO evaluation metrics, such as the loss, obviously, but also the average recall for a different number of detections, and the mean average precision that reflects the precision of the overlap between the ground truth and the predictions for different scales of objects and intersection over a union, of course. So right now I'm showing you what it looks at the end of the training, but we will see now how Arno and his team launched and managed all these experiments. So the great thing when you use a model from the Model Hub is that it often comes with an associated Jupyter notebook or Google Colab notebooks that is pre-configured, so you can see how a model was trained exactly, but also it allows you to launch the next training without having to code anything. So that's what the Rocfort tech team used to train their model. So here, everything is logged during training in real time, thanks to the Python SDK. All the files generated, such as the training weights or the model checkpoints, are saved automatically, so you never have to worry about losing or storing your work. So when you have tested several architecture, for example, Arno tested some YOLO architecture, some SSD mobile net, some faster or CNN, you want to compare the results so you can objectively find the best performing models resulting from your experiments. So you can see that one tracked information is the train test split. So it tells us the balance of the classes across the experiment for the data set. Here, if you want to compare the experiments in terms of performances, we will look at the total loss, the average recall metrics, and by looking at that, we can tell that the experiment, which is called filed or field, I think it's a typo, should be better than any other experiment. So for this, we will assume that this is our best model, and we will check the prediction on real images to see how it performs. So I chose a different image than the one Arno showed you earlier. But this is what we call the playground. So you can use your model resulting from every experiment in your project against each other and also against ground truth. to see how they performs. And if some are better than other in one case or another, for example, at night and day, that was what I was saying earlier. They are automatically deployed at the end of your training. So when you upload the train models weights to Pixelia, you can test them right away. Here we can see, so that's we tested the file model on these images, and it's already performing quite great. We didn't even adjust the threshold. We left it to 0.7, which means that our model is already pretty confident already. And this is an image from the testnet, by the way. And that's it. If you've looked at the Arnaud's demos of the modest prediction on videos of Cause, you can tell that his first prototype, the first version of his project, is quite a success so far. He did really manage to implement deep sort and deploy his model on Edge. So congrats, Arnaud. But now let's imagine that we want to deploy our model and manage a production grade project for a real business case. If Arnaud wants to sell this project one day, so what should we do next in order to complete the whole project lifecycle? So that's some subjects we work with Arnaud to help him. So you know that two ways of increasing your model's performance. There is three ways actually with the hardware choice, but the two software ways is either adding new training data. So that's the path Arnaud chose, and it's the best scenario, but it's not always possible and can be very costly. Or you can try to tune the hyperparameters of your best model to optimize its accuracy or precision or whatever the metrics you try to optimize. So to facilitate the process of hyperparameter tuning, you can have access to Pixelia scans, which is a way to automatically create a grid of experiments with parameters that respect chosen distributions, and can be initialized in one line using our Python SDK. So this removes totally the hassle of having to create all the experiments by hand, and moreover, trying to guess the best hyperparameters combinations after each training is complete. So for example, here, we were able to launch 55 training remotely, but you can also use our CLI to distribute experiments on multiple devices. And it only took us 2 hours to get the result. From what we can see, we managed to obtain a 3-time improvement on our track metric, which is our total loss here. So it's not that bad in 2 hours. Yeah. And the final step is that usually when you're happy with the first model ready for production, you have to deploy it, which can be made easy as we automatically provide API endpoint that you can request to make prediction with your model. By adding a few parameters, you can even send the images back to your dataset. So that was Satya talked about earlier. So it's quite of a circle. And you can also send the prediction, so to pre-annotate the new images with the prediction from your model. For Arnaud, as his model is running on an edge device, an alternative would be to send the images and the prediction to the platform with the API to achieve the same results. If we go further and create some workflows using our APIs, it would be able to create a fully functional active learning workflow that would allow him to continuously update his model so it stays up to date with real world data and will perform better over time. But I think that's a subject for another webinar today. Okay. So thank you for attending. If you have any questions regarding Pixelia or your project, feel free to ask them in the chat, and I'll try my best to answer you. As we don't have unlimited time, you can also contact me on LinkedIn or on the Pixelia Gitter, or even by mail. You have all the links here. And yeah, thank you.
Thanks a lot. This was great. Can I just summarize what you said so that we just summarize it before we leave. So
let's put a bow on it, Satya.
Let's put a bow on it, right? So what the platform allows you to do is, first of all, the very first step is that you need to get some data into the system. You got the data into the system, you annotate it, right? You put bounding boxes in this case when you want to detect a face detector when you want to train a face detector for cows. Now that annotation process, it's more complex than you think. You may want 4 or 5 people doing the annotation. So the platform provides multiple people to do the annotation and still have everything in one place. So that's great. Next step.
Yeah. Satya, just a sec. I just want to not forget to say that I want to thank Nikki and Wilkins for your help on the dataset building and the annotation work. It was very helpful for them, and I'm very grateful for that. Sorry for the interruption.
Oh, no worries.
And would
people who helped you.
Pierre-Nicolas, would you mind unsharing your screen here for our outro?
Yeah, sorry. No, I don't want to annotate. Okay.
Perfect, thank you.
So you had the annotation and you could have multiple people doing the annotation. The next step, once you have this annotated data, you're not 100% sure, no matter how experienced you are, you're not 100% sure which of the, there could be many architectures which are close to the state of the art, right? And the state of the art also depends on the data set you're using. So it's not always clear which of the various architectures you want to select. So basically you take a few and the platform allows you to do that and see which one for your data set, which one is performing the best, right? Now, the best architecture you take, but you're not done yet. You can actually do something called hyperparameter optimization, which means that when you're training something, there are these hyperparameters that you set. I mean, I'll pick an example, learning rate and things like that. Based on the hyperparameter, you may get slightly better results on your, the model that you get could be performing better, So it's just spending some more time on this thing. And the nice thing is that this platform allows you to do hyperparameter optimization. And it's not just one hyperparameter, right? So there could be multiple. You have to create a grid of these hyperparameters and then test which model works the best. And so once you have done with that, then you finally want to close the loop with an external API. So this external API allows you to get new data, right? Whenever you get a new data, you can apply this model to the new data and put it back in the training set. So that completes the loop. And that's pretty much how, in our consulting work also, we use all these steps to get the best performing model. So anything more you want to add, Pierre?
No, that's perfect. Thank you for the wrap up. I think it's you're right.
All right. Sorry, we went over time, but I think it was worth it. We will, people who could not make it can watch it on the YouTube channel. Thank you so much, Arnaud and Pierre. And as always, Phil, we'll see you.
Thanks, everybody.
We'll see you next time.
Yeah, we'll be back next week with Joseph Nelson of RoboFlow with his presentation, What is Active Learning and Why Does It Work?
Yeah.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Microsoft Azure and Intel, sponsors of the world's largest spatial AI competition, OpenCV AI Competition 2021. Just search for OAK 2021 in your favorite social media site. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.